because once we add a generator here, the energy from the generator is going to also go into this battery, and then the energy passes through the motor. So the generator is going to charge the input battery into the motor. That way I can actually bleed energy on both sides of the motor. I run a couple tests and it looks like it'll work. I'm going to use a Mosfet in parallel with the armature, and by doing this the Mosfet can be opened and closed, which is kind of changing the flow of energy through the FET and through the armature. So by opening the FET up, it allows more energy to bypass the armature. Not to mention being able to control the voltage flowing through the armature because they're in parallel, and if the FET is all the way open, little if any energy is going to flow with the higher resistance on the armature, which is what's energizing the generator. So what I'm hoping here is that by doing it this way, I'll be able on this small model better regulate how much power the generator's making, how much drag it's creating on the system, and there might even be a case where if I use a computer to control the FET, I can read the speed of the motor and use a program to control the FET. As the wheel speeds up and goes faster and faster, I can turn the FET off completely, dump as much energy as the motor's consuming through the armature, allowing me to generate more energy and slow the wheel down, and also be able to do these pulse where enormous amounts of energy slow the wheel down to the point where I could stop drawing it, let it off. And that's an important thing, because if we plan on building some type of supercapacitor bank on both sides of the motor, then you could charge them instantly, just like in regenerative braking on a car. You get this thing up to speed, you kick in the generator to act as a brake, you run it down to a lower speed, and then you kick it off. And you'd be able to get more energy out of the pulse motor by doing this. I know that's a lot.